Have you seen this photo before? This is an image of a famous Jeopardy match that had three extraordinary opponents: Ken Jennings, Brad Rutter, and Watson, a supercomputer designed by IBM. When the two notorious Jeopardy victors agreed to compete against Watson, they had no idea the power of this machine and they lost the match. Watson represents a milestone in artificial intelligence, and Watson's power came from an impressive technique that involves human linguistics and machine learning called natural language processing. So, what is natural language processing? Well, you run into examples of it in your daily life without even realizing it. Your phone's autocorrect or the word suggestions when you're writing a text, emails that get sent to your spam folder that you never see, apps like Grammarly that fix your essay writing, or even virtual assistants like Siri or Alexa. So let's get into the details of how all of this works. Natural language processing is a subset of AI. AI is an umbrella term for developing computers that are supposed to mimic human intelligence. The goal is to have these machines be capable of performing complex tasks, and it requires the ability to use and augment human skills like cognition, perception, learning, reasoning, and problem solving. So NLP is a specific system that uses algorithms related to human language understanding or generation. So how did Watson work? IBM's DeepQA team implemented natural language processing. DeepQA is a software architecture that takes on a philosophical approach that uses evidence-based reasoning to come up with answers. So Watson would receive the Jeopardy question and perform topic analysis. It then gathered candidate answers and evidence sources and used its own learned models combined with the statistically best evidence to generate an answer with confidence. Human language is hard, and it can be ambiguous and contextual. This is a chart that describes the techniques implemented for the examples that I gave earlier. I suggest learning more details about how these powerful techniques work, but regardless, we still have work to do. Here's a sentiment analyzer by MonkeyLearn that outputs either if the sentence has a positive or negative connotation in the computer's confidence. So let's go easy first. Today is the best day ever is positive with 98.6% confidence. How well do you think the computer did interpreting sarcasm? Or how about polarity in one sentence? Anyway, it's cool to understand how all these techniques work because language is intuitive to us. We have a ways to go before language is intuitive to machines, but as we're in the augmented age of our world, it isn't impossible.